The bridge you are seeing contains parabolic arcs. The solution to the equation of these parabolic arcs are sometimes irrational numbers, which are referred to as sets. It becomes necessary that these exact values are used. So this is one relevance of sets in real life. Let's take our first worked example. So we are solving this equation. Square root of x plus 5 equal 3. We can square both sides of this equation. And when we square both sides of this equation, we obtain x plus 5 is equal to 9. Grouping like terms gives us x equal 9 minus 5, which is 4. Now let's take another example. So the equation is square root of x minus 5 cube plus 2 is equal to 10. So with this example, we first have to group like terms. So when we group like terms, we get 8 on the right hand side. We can now square both sides of the equation, and that will give us x minus 5 cube is equal to 64. We take the cube root of both sides. So the cube root of 64 is 4. So this gives us x to be 4 plus 5, and that results to 9. Let's take another example. This time we are solving this equation. We have two square root signs, square root of y and square root of y plus 5. So we can begin by squaring both sides of the equation again. Now we use expansion to simplify the left hand side. Notice that when you square something, it means that thing times itself. The square root cancels the square, or the square takes care of the square root on the right hand side. So we expand using the distributive property. Then we use the distributive property again. Notice that square root of y times square root of y is y. And square root of y times 1 is square root of y. And 1 times 1 is 1. So square root of y plus square root of y is 2 times of square root of y. And grouping like terms, we have 2 square root of y is equal to 4. Dividing through by 2 gives us square root of y is equal to 2. We can square both sides again, and this gives us y to be equal to 4. Let's take one more example. This time we are solving square root of q minus 3 plus 1 is equal to square root of q plus 5 minus 1. We simplify by sending the 1 to the left hand side, the 1 on the left hand side to the right hand side, and that will give us the current expression you are seeing. So we can now square both sides to reduce the number of work we have to do. So if we are to square both sides here, we'll have to do a whole lot of expansion. But because we group the constant terms on one side, we will do less work. So squaring both sides gives us what you are seeing here. So this will take care of the square root. And again, notice that square root of q plus 5 minus 2 all squared will mean that this expression is multiplying itself 2 times. So we have to use the distributive property again to expand on the right hand side. So this will multiply this whole parenthesis, and this will also multiply this whole parenthesis. So let's expand. This times this will give us q plus 5. Notice that square root of q plus 5 times square root of q plus 5 will give us q plus 5, because square root of a times square root of a is a. So that is what we have here. And square root of q plus 5 times 2 will give us 2 times square root of q plus 5. Notice the sign here. Then again, we have negative 2 times the same quantity will give us the quantity we are seeing here. And negative 2 times 2, negative 2 times negative 2 give us positive 4. Now let's group like terms and simplify. Q minus cube is 0. Then 5 plus 4 will be 9. So 5 plus 4 is 9. And negative 2 q plus 5 minus 2q plus 5, 2 square root of q plus 5 will give us this expression you are seeing. So we group like terms, the constant terms on the right. And when we divide through by 4, we get square root of q plus 5 is equal to 3. So squaring both sides again will give us q plus 5 equal 9. And q will be equal to 4. Thank you for joining us. See you in another video. Please don't forget to share this video with your colleagues.